they have on pricing. So before we assumed that everyone was a price taker, everyone was competitive, that meant that if a firm tried to charge a price that was even a little bit above the market price, they would sell nothing. Or that if they tried to decrease their quantity or increase their quantity, that wouldn't change the market price at all. And this is almost never literally satisfied in the market. And in many markets, it's not even a very good approximation, especially if we want to have a more detailed understanding of what prices look like. So today we'll start studying the incentives that firms have, not just to choose how much to produce given the prices, but to try to choose how much to produce in order to influence the prices. So we'll start by talking about what a monopoly is and when we can apply it. We'll then talk about the monopolist's incentive to reduce quantity. Then about marginal revenue, which we'll develop both from a mathematical and a graphical perspective. We'll then talk about Lerner's elasticity pricing rule and how it leads us to think about the basic trade-offs that a monopolist faces, as well as alternative ways of measuring market power. We'll then talk about an example of measuring an actual monopoly demand curve. We'll then talk about deadweight loss and how it's been measured in the economy, as well as how it relates to the pass-through of taxes. Okay. Company out there, right? That's sort of what monopoly sort of means, right? But the basic mechanisms we're going to explore today are not about, there's only one firm out there, but rather apply to any case where firms don't act like a price taker, where their behavior, the quantities they produce, take into account the fact that they affect the prices in the market. You can think of them as being, in some sense, a monopolist. And the question is just then, how large of a monopoly distortion will they impose? Well, that will depend on, how much they affect prices. But the basic logic of the monopoly model is consistent with that. And therefore, we can sort of think of any time a firm affects prices, any time it does a downward sloping residual demand curve, that is demand curve given everybody else in the market, we can think of them as, in some sense, a monopoly. So the question then is, in what cases does it make sense to use a monopoly model versus a competitive or an oligopoly model? We'll study oligopoly models later in the course. And the basic things that are left out of a monopoly model, which are included in an oligopoly model, are first of all, in the monopoly model, we take as fixed the demand curve facing the firm when we think about putting a tax on the firm or putting regulation on the firm, right? But if putting some sort of regulation on the firm changes the behavior of other firms in the industry, that will affect that firm's demand curve and not just what they do given that demand curve, right? And so any such effects through the equilibrium behavior of other firms are ignored in the monopoly model. Second, the monopoly model ignores any effects on the welfare that come through the welfare. Takes away profitable sales from another firm, that can harm the other firm. That can cause a real externality on them. If they just change the prices, that's just a pecuniary externality. But if they actually change the quantity that other firms are able to sell profitably, that can be a real externality on the other firms. And the monopoly model can't take that into account because it only has the one firm that we're considering in the model. And finally, the monopoly model can never be used to study the effects of changes in the structure of an industry. So for example, if we want to think, what's the effect of the entry of another firm? Or what's the effect of the merger of two firms? A monopoly model is just not going to be very useful to think about that because it only has one firm in it, right? nonetheless, in many situations, even when there naturally involves more firms, the monopoly model can be a useful guide to us. So, for example, if we wanted to think, when another firm comes into the industry, that may make my good, that may create a substitute for my good. That may make it harder for me to influence price. The monopoly model would tell us that we might actually reduce price and therefore increase the amount that we're selling, even though we're facing a competitor. Because the elasticity of my demand, as we'll discuss in a few minutes, will rise in that case. That would never come out of a competitive model, but it might come out of a monopoly model, even though the basic force that's driving things is some amount of competition for someone else. Okay. So the most basic idea of a monopoly is that they have an incentive to reduce the quantity below the place where price is equal to marginal cost in order to raise the price at which the goods are sold. Because they want to get a higher price on the inframarginal units that they're selling. Those are the units that they'll sell regardless of exactly where the price is. And they wouldn't have this problem if they were able to charge higher prices to the people who are willing to pay a lot than the people who are willing to pay less. In that case, they wouldn't have to raise the price on everyone in order to charge a lot to the people who are willing to pay a lot. And we're going to talk more about this possibility of discriminating among different consumers on Thursday. But in the meantime, let's just think about what happens if the monopoly can only charge one price, if they've got to charge the same price to everyone. And they're not going to charge at the point where price is equal to marginal cost. Instead, they're going to reduce quantities to raise prices below that, and we'll talk about by exactly how much in a couple of minutes. But in the meantime, Vidor? Yeah. Can you think of some examples of a monopoly reducing quantity in order to try to raise prices in the real world?
Like diamond companies reducing the flow of diamonds?
That's an absolutely perfect example. Yeah. So the De Beers owns something like 85% of all diamonds in the world, and basically diamonds are not scarce. This is something that most people don't know. Diamonds are actually extremely abundant. There's like enough diamonds for everyone in the world to have like a 24-karat diamond. But the thing is, they're all in a very few places, right? So they're all in like some giant pile somewhere. And De Beers owns that pile. And De Beers just keeps the overwhelming majority of diamonds locked up underground rather than distributing them just to keep up the price of diamonds, right? That's sort of probably the most famous and powerful example. Another example is the occupational licensure example we talked about in the first class. Labor unions who try to keep people out by closed shop legislation that says you have to be part of the union in order to work at the firm. Farmers that form cooperatives to try to reduce overproduction that, destructively reduces prices in the industry. Drug cartels. If you think about what the main job of being a drug kingpin is, it is not producing cocaine. The main job is killing other people who produce cocaine. Right? So the most effective drug enforcement agency in the world are the Mexican cartels. Because their primary goal is to stop other people from trafficking cocaine, not to traffic cocaine themselves. So they really shouldn't be called drug traffickers. They should be called drug enforcers. So in fact, when Pablo Escobar, who is probably the most effective drug kingpin of all time, was killed by the U.S. government, the prices of cocaine dramatically fell and the quantity of cocaine coming to the U.S. dramatically increased. Because basically the main thing he was doing our job as the United States of eradicating coca. The main thing he was not doing was bringing cocaine to the U.S. It was reducing the cocaine that was brought by everybody else. Similarly, drug companies, legal drug companies, invest lots of money in making sure that the drugs that they sell in developing countries don't get re-imported into the United States, because they would reduce the prices there. Similarly, I don't know if any of you has ever been the subject of a lawsuit by one of the record companies, but many students often are because they're like downloading massive amount of stuff illegally. Those lawsuits are specifically designed to reduce the availability of music to try to raise its price, right? Okay. So in order to represent this, we're going to think about the revenue function, which is the price times the quantity, right? Under perfect competition, you would set price equal to marginal cost, but now you're going to set the derivative of your revenue equal to marginal cost, and that's no longer just price, because the price can change when the quantity changes. And by the product rule, Eric, is Eric here? No, he's not. Eric Wan? No. Does anyone else want to just do the product rule on my revenue and tell me what the marginal revenue is? Yeah, go ahead, Tejas.
So P times Q, like that is PQ is one variable, right? Or,
yeah.
So then plus P prime Q times Q, right? Because it's the first.
Yes, that's exactly right. That's exactly right, Tejas. So that's just the product rule, right? So as Tejas said, the marginal revenue is the price, and that's the part we want to be there, right? Because they're going to set marginal revenue equal to marginal cost. So if we didn't have this second term, we would be in business. It would just be like competition. But unfortunately, we've got this P prime times Q. What is that? If I increase my quantity, I reduce the price that I get on all the units that I'm already selling. So this is the inframarginal quantity, and this is the reduction in price that comes from increasing my quantity. And so this means that, first of all, the second term is always negative. So the marginal revenue is always below the demand curve as long as demand is downward sloping. And this gives me an incentive to reduce the quantity. That is, in order to raise the price on the inframarginal goods. And the distortion is going to be proportional to the amount that I'm selling, the inframarginal quantity, and how much the price changes when I increase my quantity. That is, the more I'm a big player, I'm selling a lot and I affect the price a lot, the more I'm going to want to reduce the quantity. Okay, so let's go through and derive some examples of marginal revenue curves using the most common demand curves. So first let's start with the quadratic demand curve, which is a concave demand curve. And Justin Cipiora? No. Anyone else want to tell me what the marginal revenue curve associated with this is? Yeah, go ahead, Amanda.
Okay, so we have to first derive P of Q. P of Q is going to be...
Well, this is P of Q up there, right?
Yeah, P prime of Q.
Yes.
Is going to be minus 2Q squared. Minus 2Q, and
Yes.
then you have to multiply it by Q,
Yes.
which is going to be minus 2Q squared.
Yeah.
And then you have to get PQ and subtract that from PQ.
Yep. So there's P of Q, so that's 1 minus Q squared.
Minus 2Q squared.
So we get 1 minus 3Q squared,
Yes.
right? Very well done. Okay. So the thing to notice about this is that this diverges increasingly rapidly from the demand curve, right? If the quantity is equal to 0, they're both 1, right? But then this quadratically diverges from this, right? So as Q gets bigger, these get further and further apart from 1, right? Okay, how about for linear demand, Suraj?
So multiply P of Q times Q, so that gives you Q minus Q squared.
Yeah?
And then derive that, so that's 1 minus 2Q.
Exactly. So this is going to, again, be the same as the demand curve when the quantity is 0. And it will diverge from it. It's steeper than the demand curve is, so it'll move apart. But it'll move apart at a constant rate. So this one diverged increasingly quickly. This one diverges at a constant rate. Okay. how about exponential demand? Is Cole here? Cole Walters? Okay, does someone else want to do exponential demand? Yeah, go ahead, you talk.
So it's the formula is PQ plus prime PQ times Q. So
Yeah.
it's 1 minus log Q plus derivative of that is 1 over Q times Q.
Yeah.
It's 1 minus. So that's 1 minus log Q minus 1.
Yeah, and what's that?
Equals minus log Q.
Exactly. So it's exactly minus log Q. And so the demand was 1 minus log Q. This is minus log Q. So these have exactly the same slope. It's just that this is below this by 1 unit, right? That's the only difference. Right? This is just 1 below it, and it's always 1 below it. Okay. How about for this constant elasticity, David? Can you derive for this constant elasticity demand, 1 over Q to the 1/2, what the marginal revenue curve is?
So I take the derivative of P of Q.
Yep.
And it's negative, I think, 1 over 2Q to the 3 over 2.
Yep. And then what do you do with that once you get it?
And then I multiply that by Q and then subtract it from Q.
Yep. And so,
We get 1 over 2Q to the 1/2.
yes, I think that's right. Yeah, exactly. Perfect. So this one is exactly half of this one, right? And because the demand goes down as the quantity increases, this means that they're going to get closer and closer as the quantity increases, right? So when the quantity is very small, these will be very different. As the quantity increases, these will go down, and they'll get closer. So that is, the marginal revenue is a constant fraction of the price, and therefore they'll get closer as the quantity increases. So just to give you pictures of these, this is the constant elasticity demand, and you see the marginal revenue is a constant fraction of the demand. Here's the linear demand. They start at the same point and then they diverge at constant rates. Here's the negative exponential demand. There's a constant difference between them at each point. And here's the concave demand. They start at the same point and then they diverge increasingly rapidly. Right? Now, what I've done here is I've depicted the horizontal axis as being the marginal cost curve, so that we can figure out how we figure out what the firm's correct quantity and price is. So if the marginal cost curve is the horizontal axis, we find the intersection between that marginal cost and the marginal revenue curve, which is the red curve in each of these. We then draw a line up from there, because that's the optimal quantity, right, to what price that corresponds to, which is on the demand curve. And we draw a horizontal line over to determine the price that corresponds to. Right? And that's what we've done on each of these. We find the intersection between marginal revenue and cost, take the line up to demand, and over to find the price. That's the general way that you find the price associated with the monopolist optimal price. Okay. So another way to write marginal revenue is as the price times 1 minus the inverse elasticity, 1 over the elasticity. And Xiaolun, I might be pronouncing this wrong, Xiaolun, Xiaolun Cheng, Does anyone else want to explain how we get this? Well, I'll just go through it. It's fine. So, the elasticity, right, is the negative of the derivative of quantity with respect to price times price over quantity, right? That's the elasticity formula. Because this is the percent change in quantity for a percent change in price, right? So that's the same as 1 over the elasticity being the percent change in quantity over the percent change in price over the percent change in quantity, right? Which is dp dq times q over p, right? So that says that price divided by the elasticity, if we multiply both top and bottom by price, we can cancel the two prices. And we get negative of the price over elasticity is p prime times q, right? And that's exactly the difference between marginal revenue and price. So, if we then just bring price on the other side, we get that marginal revenue is equal to price times 1 minus 1 over the elasticity. Okay. So what that tells us is that a firm is never going to produce at a point where its elasticity of demand is less than 1. The reason is that if the elasticity of demand is less than 1, then the marginal revenue will always be negative, right? Because in that case, the monopolist will actually be able to get more revenue by producing less of the good. And given that they have to pay more cost when they produce more of the good, they're never going to want to do that. Okay. The second thing to notice is that the elasticity of demand is the key determinant of the monopoly power. Because if the elasticity were infinite, so this whole term were 0, then the price would just be equal to marginal cost, right? So as the elasticity gets smaller, the firm has more monopoly power. And this is pretty intuitive given what we said before, because the elasticity sort of measures how big of a firm am I in the market. If I increase my price by 1%, how much does that change the demand? If it changes it by a ton, if the demand curve is very flat, I can't affect prices very much. If it changes it by a little, then I'm a big part of the market, and I can affect prices a lot. Okay, so if we rearrange this formula, if we set this equal to marginal cost, and then we bring price times the elasticity over onto one side, bring marginal cost onto the other side, and divide by price, we get price minus marginal cost over price is equal to 1 over the elasticity. This is called Lerner's markup pricing rule, or elasticity pricing rule, and it says that the difference between price and marginal cost divided by price is 1 over the elasticity. So this is a reason why elasticity is often used as a way to measure market power. If elasticity is low, you have a lot of market power. And so as a result of that, sometimes in antitrust, people will use the difference between price and the markup and cost divided by price as a measure of how much power the firm has in the industry. Okay. This number is often called the markup, but it's really a relative markup. It's the markup relative to price. Markup being the difference between price and marginal cost. You could also do the markup relative to marginal cost rather than relative to price, and you would get 1 over the elasticity minus 1. Or you could do the ratio of price to marginal cost. That would give you the elasticity over the elasticity minus 1. Or you could do the absolute markup, just the difference between price and cost, and that would give you the price over the elasticity. These are basically all alternative and very similar ways of measuring market power, but in some contexts, one can be more useful than the other. So the standard Lerner formula is quite nice because it's just very simple. It's just 1 over the elasticity. So when the elasticity is easy to measure, or is salient, or you can think about it easily, we'll use this formula. The price-cost ratio can be useful because it's especially when marginal cost is constant, it's very related to the profits that the firm makes. Just the straight markup can be useful for the same reason. The absolute markup is particularly useful when costs and therefore prices may not be positive. So a good example of that would be advertising markets. So many newspapers and many websites are given away for free, or the price is 0. So in that case, the ratio of P minus MC to MC, to P is going to be infinite. It's not even going to be well defined, right? And the reason that they give things away free is because actually their costs of having someone read the newspaper are negative, because they're getting paid by the advertisers to hand out the newspapers, right? So in that case, using the Lerner pricing rule makes no sense, even though the firm has some market power. Okay. Or credit cards are another example of that. People pay you to use your credit card, right? You get points every time you use your credit card. And the reason is because they're making money off the merchants every time you use the credit card. The marginal cost of having used the credit card is negative. And so it doesn't make sense to use the inverse elasticity. Okay. Now, in order to set prices, in practice, firms don't just like automatically know what the demand curve is, right? They have to try to figure that out. One way that they can do that is by experimenting with the price that they charge and seeing what the marginal revenue looks like. And in the past, firms had to sort of guess about this or gradually try out different prices and try to learn. Because the internet has really totally changed this. So in the internet, you can very easily try charging different prices to different people, and you can really figure out a lot about what demand curves look like. And many companies do this all the time. So Amazon, almost every time you go onto Amazon, it's like trying a different price to see whether you'll buy or not. And probably the most common platform for experimentation like this is eBay. So people on eBay, sellers on eBay, are constantly experimenting with the reserve price they charge. This is the minimum price that you need to pay in order to win the auction. And the way you can figure out that they're doing this is the exact same seller is selling the exact same thing for different prices on different days or at different auctions at the same time. And this auction can actually generate, now you'd think that this is like the minimum price that you need in order to win the auction, not like the price directly that they're selling the thing for, right? So it's not exactly the same as a demand curve, but it's actually quite closely related. And Sam, could you explain why in an auction the reserve price could be quite similar to the price in a normal auction, or how they might be related, or in a normal demand curve, and how they might be related?
Sure. So the average price is going to go up, just like in the demand curve, when the minimum price that people are bidding goes up.
Yeah. So why might that happen?
In the auction or in,
yeah.
in the demand curve? Isn't it just like if someone's willing to pay higher, then
yeah.
like the average is going to be higher, just intuitionally?
Yeah. So exactly. Imagine that Sam bids above the reserve price, but everybody else bids below the reserve price, right? And imagine that Amanda was the second highest bid, right? If the reserve price hadn't been that high, then you would have paid the price that Amanda bid rather than the reserve price, right? And so having a higher reserve price means that if I sell it, at least on average, I'm going to sell it at a higher price, right? So go on with what you were saying. You're then going to say, why? What else happens when I raise the reserve price?
When you, I don't know. I just know that like the average would.
Yeah. So that's very good. Does anyone else want to say what else happens when you raise the reserve price? Yeah. Go ahead.
Doesn't the average price go up?
Yeah, that's what Sam said. but what else? But what else happens? Yeah.
Don't have less of a chance of selling something.
Yeah. Exactly. So why why would you have less of a chance of selling it?
Because you're decreasing the difference between your S and the new sale price. So the old sale price and the new sale price,
Yeah.
so there are less people who are willing to buy it at that price.
Yeah, so there's a chance that no one will bid above the reserve price, right? Exactly. And in that case, you'll fail to sell it. So you can sort of think of moving around this reserve price as being like, I'm using this to move around my average price, and as the average price moves up, the probability of sale moves down, right? So it's just like a demand curve, right? The higher the average price, the lower the probability of sale. And this is exactly, yeah, go ahead.
Aren't a lot of websites not allowed to do this anymore? Like non-auction websites like Amazon?
Yeah.
They're not allowed to track your IP and see how many times you visited a product page or something?
Well, actually, they do still a lot of it. But the point I was trying to make was not that they would track you individually, but just that they would randomly, for different people, try charging them different prices, see how many people buy at different prices, and use that to trace out the overall demand curve rather than individual people's demand curve. So, Einov et al. Got this amazing data set. So they went to eBay and they got every piece of data eBay has. Every demographic information, everything that they have about everyone who's ever sold or bought anything on eBay. And every transaction, everything. And so what they did is they used this to draw out the demand curves for auctions. And the amazing thing is they found that almost all the demand curves had exactly the same shape. That is, they found that no matter which category of product you were talking about, or how valuable the thing was, the shape of the demand curve looked almost exactly the same. But this turned out to be a very funny shape. So the marginal revenue curve associated with this was actually increasing in some parts. It wasn't decreasing like the ones we were talking about. And here, the marginal cost is constant. Why? Well, the marginal cost is just, as a function of how often you sell the good, is just your value for not selling the good, times the probability with which you sell it. And so that's just constant marginal cost, right? The total cost to you is the probability you sell it times your value for it, and that's constant in the probability that you sell it, right? And so because the marginal revenue curve decreases, increases, and then decreases again, there may be multiple intersections between the marginal cost and the demand, marginal revenue curve. And so what this means is that at some point as my marginal cost increases, I'm going to jump from selling with a high probability to selling with a lower probability. Just like when we looked at those wiggly marginal cost curves, as the price rose, we jumped from selling a lower quantity to selling a higher quantity. And one way we can represent this is with what's called an ironing line. So this is a line which starts, which is sort of such that if my marginal costs were below this line, I would charge the high quantity. If my marginal cost is above this line, I'll charge the low quantity. I'll sell the low quantity. And in order to construct this, what I did is I took all their demand curves, which are all very similar, and I drew a curve through them, which fits them very nicely. It's a third-degree polynomial fit. And I used this to build the marginal revenue curve, and then I drew in the ironing line. And the ironing line, as you'll see here, so let me just describe what I did. So here's a bunch of these demand curves that they drew, that they found for different categories of the value of the product. And then to make their prices all similar, they took sort of the average value of that product and they just normalized the price by that. And so here's what the demand curves look like. As you see they're sort of pretty normal here, but then they get super convex here. They just like flatten out a ton. And here's all the kinky ones that they have. These just come from real data. But then I drew this blue line, this blue curve, which is a nice smooth fit through those curves. Right? Just so that we can take the derivative of it. Taking the derivative of it gives us this marginal revenue curve, which, oh, look, it goes down, but then it comes back up again, and then it comes down again. And so I drew this ironing line through it, which is the line such that the area above this line and below the curve and the area vice versa is the same. That's exactly the line where if my marginal cost is below this, I'm going to produce over here. If my marginal cost is above this, I'll produce over here. And so what that means is that if my marginal cost is slightly below this, I charge this price. But if it's slightly above it, I charge this price way up here. Which means that no one will ever charge a price between here and here. That is, when my marginal cost increases by a little bit, my optimal price jumps up to this higher level. And in fact, that's exactly what you see on eBay. So if you look at the reserve prices, they're either at about like 40% or below of the value of the object, in which case you're selling with a very high probability your expected price is way down here. On the other hand, if you other goods sell at a reserve price of about 80%, in which case you're over here. And almost no one is in between, which is exactly what you would expect from this analysis. Okay, so monopoly has two basic effects on welfare in markets. The first is that it raises prices. And the main effect of raising prices is to transfer resources from the consumers to the monopolists. But on the other hand, and that's really just a transfer. That's not a loss, deadweight loss to society. It's just moving money from consumers to monopolists. But it has a second very important effect, which is it reduces the quantity sold inefficiently. And that is a deadweight loss. And the question is, how do we know that that's a deadweight loss? How do we know that it's inefficient to reduce the quantity below the place where price equals marginal cost? Calvin, how do we know that that's inefficient?
Well, if you're not going to, basically it's not at P equals to MC, so it's not parallel efficient.
So just describe intuitively what's happening when the quantity gets reduced below that point. What's the problem?
Basically, you have a case where price is greater than marginal cost.
Yeah.
So in that case, like some people who want the product will not be able to get it. Exactly.
So there's some people who are willing to pay more than it costs society to produce the thing, and yet they're not being served, and that's inefficient, right? Okay. Again, the reason why this occurs is because the firm would like to charge high prices to the inframarginal people, but make sure that the marginal people still get served. But it can't do that. It would like to avoid the inefficiency that it causes, but it can't avoid that and still charge high prices to the inframarginal people. Right? So there are many examples of this type of inefficiency in real life. So for example, music isn't freely available to anyone who wants to listen to it. You have to pay for the music. And Eric, why is that inefficient, that music isn't freely available? Or like movies or something like that. Like just pure information goods. Why would it be more efficient if anyone could, download any song they wanted for free? From an economic perspective, why would that be more efficient?
Because then everyone would want to listen to it.
Yeah, but in particular, it doesn't cost anyone anything. If you listen to music, that doesn't cost anyone else anything, right?
Right.
And so those should be freely available to people because they have no cost, right? Anything that has no cost should be available for free, right? But it's not because someone has a patent over that, someone has a monopoly, and they use that to raise the price, right? And that's an inefficient loss. from the monopoly power. Another good example of that is, often you notice if you go to a really big city that sometimes of day when it's not so busy, you'll go into a parking lot and many of the parking spots in there will be empty. Even though there are people constantly roaming around the streets trying to find a place to park for less. That's totally inefficient, right? Nobody would lose anything if people just parked their cars in those parking lots. But because they have market power, they raise the price so as to, and they reduce this, and then people spend all this time roaming around the streets of the city looking for a place to park, right? And that's clearly a waste of time and energy, right? So, effectively, monopoly means that consumers create an externality for the firm, right? Because if the consumers buy more, then the firm is going to make more profits, right? It's making a profit for every person who buys the product, which is the markup. And that's not mediated through the price system, right? There's no one who's gets an offsetting cost when the consumer buys from that firm. And therefore, it's an externality. And this naturally suggests a Pigouvian solution, right? We said whenever there's an externality, there should be a subsidy, right? You could subsidize people purchasing goods from a monopolist. Or you could just regulate the firm's price to be down equal to marginal cost. Or you could have a cap and trade, where you say the firm has to produce exactly a certain amount, which is the efficient amount. And some of these things are used in practice. In fact, that's what we're going to explore in Lecture 12. But they're much less common than you would think, given our analysis of externalities. In Lecture 13, we'll talk about some of the reasons why. Another common solution to this problem is if certain, like you sort of explored on your problem set, one solution to externalities is if there's prestige associated with something. So one solution to the products not being bought enough is if monopoly products are thought to be prestigious or socially valuable, that can help deal with this inefficiency. One way to do that is firms can advertise their products and try to make them cool, and this can make people buy them even for more than they would really be willing to pay for them. So for now, we're going to treat it as if this cannot be easily internalized, as if it's a real deadweight loss. And to the extent it is, we can just measure it like we do any other deadweight loss, right? It's the triangle formed by the amount of the externality or the amount of the tax and the efficient quantity, right? In particular, we can measure the deadweight loss triangle. The only difference here versus any other deadweight loss triangle is that the size of it is determined by the monopolist's optimum. So it'll have a particular relationship to monopoly profits that we'll explore in a couple minutes. So the triangle is going to be the area bounded by the supply curve, the demand curve, and the equilibrium quantity. And the monopoly profits can be measured graphically in two ways. They're either the area between the price and the marginal cost curve, right? Because the price times the quantity is the revenues, and the area under the marginal cost curve is the cost. And so the area between the price and the marginal cost curve is the profits. Or you can measure them as the area between the marginal revenue curve and the marginal cost curve. Because if you add up all the area underneath the marginal revenue curve, that's the total revenues. The area underneath the marginal cost curve is the total cost. Similarly, you can measure consumer surplus in two ways. It's either what we usually do, the area between the demand curve and the price, or you could think, well, imagine if the monopoly could charge everyone exactly what they were willing to pay. Then the consumers would get no surplus, and the monopoly would get the whole area between demand and marginal cost. So the consumer surplus is what the monopolist isn't able to get, right? It's the area between the demand curve and the marginal revenue curve. Because the monopoly is only able to get the marginal revenue curve, but if it could get everything, it would get the demand curve. So, let's look at all those areas on the graph. Monica, could you point out which area is the area of deadweight loss in this graph? So here we've got the marginal cost curve, the marginal revenue curve, the monopoly's optimal quantity, and their optimal price. So where's the deadweight loss curve? Here. What? No. Remember, it's the area between the equilibrium quantity and the demand curve and the marginal cost curve. It's E, that's right. That's right. So it's E, because here's the equilibrium quantity, here's the efficient quantity, here's the triangle formed between those. Right? Okay. Now, Terrence? Terrence Polk? No? Anyone else want to point out the two areas corresponding to the notions of profit I said? The area between price and marginal cost, or the area between marginal revenue and marginal cost? Anyone else want to point those out? Okay, so the area between, this is price here, and marginal cost is here, so the area between them is C plus D. Right? On the other hand, the area between marginal revenue and marginal cost is C plus A. Both of those should be the same because both are equal to monopoly profit, and that's exactly what we get because the area A is equal to the area D. They're similar triangles. Right? Okay. Isamar, could you point out the areas that correspond to consumer surplus? Either the area between demand and the price, or the area between the demand and the marginal revenue.
B and D.
B and D, that's the area between demand and marginal revenue, right?
And A.
Yep.
Yeah.
A and B, right? Because that's the area between demand and the price. And again, these are equal because A is equal to B. So the area between A plus B is equal to B plus D, right? Okay. So when a tax is imposed in a competitive market, right, the consumers and the producers share the burden of that tax, right? This is what you learned last term. The price rises by somewhat. It doesn't rise by the full amount of the tax. So the price to the producers goes down some. The price to the consumers goes up some. In fact, if supply is perfectly elastic, right, the price will always rise one for one. So it only depends on the elasticities. Here's the classical formula for the incidence of the tax. 1 over 1 plus the ratio of the elasticity of demand to the elasticity of supply. On the other hand, under monopoly, the slope of the marginal revenue curve is also really crucial. It's the curvature of demand, rather than just its elasticity, that's going to be really important. If the market is if the demand is highly elastic, if we're close to perfect competition, then the formula will be very close to this. But if the market is highly monopolized, if the elasticity of demand is low, then the curvature is going to be crucial. The curvature of the demand curve, which determines the relative slope of the marginal revenue and marginal cost curve. And the reason is the curvature is going to determine how sharply peaked the monopoly's optimal price is. So what do I mean by that? If we graph the monopoly's profits as a function of their price, they might look like this. Like, this is by far the best price, and if I charge even a little bit off from that, I lose a ton of profits. Or they might look like this, right? Very flat, I'm pretty close to indifferent across a range of prices, right? If they're very, very peaked, that means that there's sort of just like one best price that the market will bear. If I charge anything other than that, I'm an idiot, right? So a small change in my cost will not change that calculation very much. Even if my cost increased by a bit, I'm still going to want to charge this one best price, pretty much, right? So the amount that I want to increase price when my cost increased is very small. On the other hand, if I'm close to indifferent over a wide range of prices, a small change in my price will lead me to dramatically increase my cost, will lead me to dramatically increase my price. This is very similar to what happened with that non-monotone marginal revenue curve, right? If I'm sort of indifferent between charging this very low and very high price, if my cost increases by a little bit, I jump up to the high price from the low price. And the same thing can happen even if it's not an infinite pass-through rate. It could just be very high if I'm close to indifferent over a range of prices. So yeah, the INOV data was a very extreme example of this. If the marginal revenue curve actually slopes up, if the second order condition is violated, the monopolist will actually jump up in terms of the price he charges for a small change in cost. So let me just give a graphical representation of this. So here's this is a little bit hard to see, but here's the concave demand curve I showed you before. And here's its marginal revenue curve, which, remember, diverges increasingly fast as the quantity increases. Then if I have my marginal cost increased by a unit, that doesn't move me very fast up the marginal revenue curve because it's very steep. And therefore, I only move a tiny bit on the price. So the price increases by half as much as the marginal cost increases. Right? On the other hand, if I have this constant elasticity demand curve, where the marginal revenue curve is very flat, it's converging with the demand curve. Then if I increase my marginal cost by a little bit, I move all the way down this marginal revenue curve, which moves me a ton along with price, and price increases by twice as much as the marginal cost curve increases. On the other hand, the supply side factors also influence it, that were even relevant in the competitive analysis. So if my marginal cost curve increases by a bit, and the marginal cost curve is an increasing function, then my price increases by less than the marginal cost does. On the other hand, if my marginal cost is decreasing, and I increase it by a bit, I move more along marginal revenue, and so the price increases by about the same as the marginal cost curve does. Okay. So the same exact properties determine how surplus is divided between consumers and producers. So think about what makes a monopolist have sort of a single best price that they could charge. Well, it's basically that they say, look, if I charged a little bit less, I'm not going to get much more demand. Right? If I charge a little bit more, well, there's not much consumer surplus, so there's not much I can capture by raising the price by a bit. So that's saying that there's not much dead weight loss because demand wouldn't increase much if I reduce price. And there's not much inframarginal surplus because I couldn't really charge much higher of a price if I raised it. And so they're sort of capturing everything there is to capture, right? And that's exactly what happens in a concave demand curve, right? If the demand curve is very concave, there's not much consumer surplus above, and there's not much dead weight loss to the right. On the other hand, when will a monopolist be close to indifferent over a wide range of prices? Well, if there's a ton of consumer surplus, well, they might be tempted to try to chase after that with a high price. And if there's a ton of dead weight loss, they might be tempted to try to get rid of that by charging a lower price. That's what's going to make them indifferent over a wide range of prices, and that's exactly what happens with a convex demand curve. There's a bunch of consumer surplus above, and there's a bunch of dead weight loss to the right. And so the cost properties are the same idea, right? If my marginal cost is increasing, then I'm going to have a lot of profits, right? But as we studied before, it's the area, if the marginal cost increases, that gives me a big area underneath the price and above the marginal cost curve. And that's also going to lead to a smaller pass-through. On the other hand, if marginal cost is very flat, that's going to make my profits very small. And it's going to mean a larger pass-through. And if I have, and in fact, the marginal cost curve is also going to reduce the area of deadweight loss. If it increases, that's going to make deadweight loss smaller. If it's flat, it'll make it larger. And so the pass-through actually turns out to be exactly the same as the way that the surplus is divided between consumer surplus, producer surplus, and deadweight loss. The ratio of consumer surplus to deadweight loss and the ratio of consumer surplus to producer surplus and the ratio of deadweight loss to producer surplus are both equal to the pass-through rate. So you can see that again in this diagram. On the left-hand side, we had the cases where the pass-through rate was small, and you see here the consumer surplus is very small relative to the monopoly profit, and the deadweight loss is very small relative to the monopoly profit. Similarly here, consumer surplus, small relative to profit, deadweight loss, small relative to profit. On the other hand, here, where we had very high pass-through, here's the monopoly profit. The consumer surplus is this whole giant area up there, right? That's very big relative to the monopoly profit. And the deadweight loss is this whole big area through there, which is big relative to the monopoly profit. Similarly here, the consumer surplus is now big relative to the monopoly profit, which is just this area in here, because the marginal cost was decreasing, and the deadweight loss is also going to be big relative to that profit. Okay. Now, in the 1950s, Arnold Harberger tried to measure how much deadweight loss there was in the U.S. economy as a whole. And Ri Yang, how did Harberger try to do that?
He first identified the abnormal profits was monopoly.
You're just reading off the slide. You're not going to be able to explain it. Okay. Did anyone actually read the Harberger article? No. Nobody. Yes.
I didn't really understand it.
Okay. That's good. Go for it.
So like, as far as I can tell, he was looking at like the late 20s.
Yeah.
And like trying to tell if like there was like trying to see the effect of monopoly power in terms of how much like they would have lost compared to not having monopoly power.
Yeah.
And then he did a lot of math that I didn't quite understand.
Yeah.
And he came out with some number that was like lower than what economists predicted.
Yeah.
But was like still kind of big. And his conclusion was that maybe monopolies like have like less of an effect on stuff.
That's right. So let me try to explain the math that you didn't understand. So basically, what he did was he identified the abnormal profits that firms made with monopoly power. That is, he looked at sort of like what was the average rate of profits, and he said any extra profits that a firm making that's monopoly, that's coming from their monopoly power. That's above the normal thing. Now that assumes that there's the way he did that was he just looked at the profits the firms were making, and he assumed that was monopoly profits, and any abnormal profits were monopoly profits. That comes from an assumption of constant marginal cost, right? Because firms could be making an abnormal amount of profits, as you did in your second problem set, as you saw there, just because they have an increasing marginal cost curve. But if you marginal cost, then any profits above the usual come from being monopoly, right? He second assumed all industries had a constant elasticity of 1, which lets you calibrate the relationship between the monopoly profits and the deadweight loss, because it ends up assuming a particular pass-through rate, right? So this allowed him to determine the size of the deadweight loss area based on the size of the abnormal profits. And third, he assumed that within a particular industry, there was no abnormal profits. Everyone within the industry was making exactly the same profits. All firms had the same monopoly power. And then he got data on the profitability of different industries from accounting information and so forth, and he compared this, and he determined the average degree of profitability, and then figured out that anyone who was above that was making monopoly profits and was creating some deadweight loss, according to this assumption. And he used this to back out the degree of excess profits, and therefore determine how much resources would have to be reallocated given this deadweight loss in order to eliminate the deadweight loss, and that allowed him to calculate the total amount of deadweight loss created by monopoly in the economy. And he found something very surprising that Fedor pointed out, which was that the total deadweight loss from monopoly was extremely small, about 1/10 of 1% of GDP. Absolutely tiny. And the basic reason is that the area of the triangle is usually small relative to the area of the square, of the rectangle, right? So imagine that, like, monopoly elevates prices by 5% above the level that they should be at. Then the area of the deadweight loss triangle is going to be 0.05 squared, which is like 0.0025, right? So that's going to be tiny. So unless monopoly profits are like huge in some areas, the amount of deadweight loss that causes is going to be very small. So if there's a lot of small monopoly distortions in a lot of industries, it's going to have very little impact. Only if there's giant monopoly distortions in some areas does it really make a difference. And an important implication of this is just because in economic theory we study monopoly distortions, and just because we talk about it, just because we talk about lots of things in this course, doesn't mean they actually matter in the size of those effects in the real world. Just because they could in principle matter, doesn't mean in practice they do matter. So it's really important that we, not just think about things conceptually in this course, but that we actually try to think, well, how big is that effect? Does it actually matter, or is it just something that I came up with in the ivory tower? Nonetheless, even though I think that's a very important point in general, I think there was a lot of problems with Harberger's analysis. Does anyone see any of problems with the assumptions that he made? Yeah, what do you think, Bernard?
Well, there were like 5 pages where we went on like problems with this. The one that I remember, they were like generally below 1. The one was the highest one or something like that.
Yeah, so that would lead this to be an overestimate, but I think that it's a giant underestimate. Can you guys think of any reasons why it might be a giant underestimate? Hint 1 is related to problem 2 on your on problem set 2. Yeah.
Well, we assume that all the firms have constant returns to scale. Whereas I guess in monopoly, like they have increasing returns to scale.
Yeah.
So that they would produce more.
Yeah.
Like output will be more.
What's your name?
Eason.
Eason.
With a less increasing cost.
Yeah, that's exactly right. So he assumed constant returns to scale, but monopoly most often arises when one firm can produce more efficiently than a lot of firms, right? And in that case, the deadweight loss is going to be much bigger for the reasons we talked about, right? If there is increasing returns, deadweight loss could be huge, right? So that's a big reason that he underestimated. Another reason, which is related to your problem set, is that we saw that because of Zipf's law, some firms in an industry are much bigger and much more profitable than the other firms in the industry, right? That's all within one particular industry. And he was assuming that all firms in the same industry make the exact same profits, right? So that's sort of wildly unrealistic, right? He was assuming that all the misallocations were happening because some industries were more profitable than other industries. But in reality, most of the differences in profitability are within an industry. That the best firms are much better than the worst firms, right? So like compare Apple Computer to like Motorola or HTC or all these other companies that make tiny profits compared to what Apple makes, right? And so a huge amount of the misallocation is within industry, not across industry, and he completely ignores all of that. Similarly, the elasticity of demand, as Fedor pointed out, was very heterogeneous and not necessarily exactly equal to 1 everywhere. Nonetheless, I think we can still take some important broad lessons away from Harberger's work, which is one is that monopoly distortions exist but that doesn't necessarily mean that they're large. I love antitrust policy. We're going to study it a lot in this course, but that's not necessarily the most important area of policy for the economy broadly. You should be skeptical and constantly question how important the things we talk about are, not just because we can show in some model that something arises doesn't mean it's a huge or important effect for the economy. As prices increase, initially the dead weight loss area may be very small, even though the firms can make significant profits, right? Because one is a triangle and the other is like a rectangle. And what that means is that a bit of market power, but not full monopoly, may create large profits for the firm without creating too much dead weight loss. And so as we start to get some market power, first we create profits, and then later we create dead weight loss. It's not like those things come at the same time. And so another thing that tells us, so in the analysis that we were doing, the only thing that mattered for the ratio of dead weight loss to monopoly profits was the pass-through rate, the curvature, not how competitive the industry was. But on the other hand, if we start from a very competitive situation and just start raising the price a bit, initially the dead weight loss area is very small, but the monopoly profits are large, right? So those things seem to be inconsistent with one another, and the key reason is that in a very competitive market, if I reduce my quantity, that primarily benefits the other people in the industry, not me. That primarily benefits my competitors, who now get to make the profits on the amount that I'm not selling, rather than benefiting me, who raises the price, because I have a real externality if they're selling more, and that means that the monopoly model really overestimates the amount of dead weight loss. Because the monopoly model says when I sell one more unit, that brings the benefit of the markup to society, right? But in reality, it also takes away the markups that my competitors are earning. If I, by selling more, reduce the quantity that they're selling, that doesn't bring the markup as a benefit to society. It brings the markup minus the markup that all my competitors are getting. And that means that the dead weight loss under the monopoly model is really a big overestimate in most cases of the actual dead weight loss. In fact, the dead weight loss could be negative. If the other firms all have a bigger markup than I do, and I increase my quantity and take away some of their sales, that could actually be harmful rather than beneficial. The overall externality could be negative. Finally, the primary impact of monopoly may not be the dead weight loss that it creates. Even though that's what we focused on when we said, hey, look, the transfer of the monopoly, that's just a transfer. That transfer could be the main effect that monopoly power has. And we're going to come back to why that's so important in Lecture 13, because the profits that monopoly earn act as an incentive for the monopoly to get into the industry in the first place. And finally, details. Things that might seem like details, things that Harberger brushed over, may actually be really crucial for us measuring these types of effects. The heterogeneity of different firms in an industry, the exact structure of cost, those may be the most important things for us to measure. So we're done, but if you guys want to, we've got 10 minutes, if you want to ask questions about the midterm, we can do that. I can tell you what's on the midterm.